A very good morning, class. Good morning, Sumit. Class, very good morning. Good morning, everyone. Arman, Arkhan, Neha, Vaibhav, Ayush, everyone. Very good morning, guys. So, hope your vibas for the project were fine yesterday. Good morning, Jyotsna. How were your viba, internal vibas for your projects? All right, great. So, guys, let's continue with our today's topic on the area of computer networks. Today we will be talking about the subject called routing for mobile host. So, guys, till now, whatever networking we have studied and whatever either IPv4 or IPv6 we have talked about, most of the things we have focused were in the context where the end host is stationary and doesn't move as such, right? So even if we talk about our very own IPv4 based networking structure or even the IPv6 based network structure, so all those IP addresses they are hierarchically arranged, and that hierarchical arrangement is in a way that by traversing the architectural tree of the whole arrangement, we can finally locate out where a particular node is in the whole network, right? So that is the basic thing with either IPv4 or v6. But when it comes to the mobility, when it comes to a mobile unit which keeps on more one part of the network to another part of the network, it becomes really hard to keep delivering data to the end host. Two possible ways are there, right? So a very first way is, since suppose I'm first going to go for one whiteboard discussion with you for this. So let's suppose this circle over here, it represents the uh, node A's network. Now let's have a node A. So suppose this red rectangle represents a node, what let's call it as a node A. Now, when node A is in its home location, how it works and behaves, let's understand that. Now, suppose when node A is located over here in its ISP's network, then suppose its IP address is 10.0.0.2, right, slash 8 notation. Suppose this is its IP address. Now, what happens if suppose this A has to move into a new area? Now, suppose this A has to move uh, to a new area, like suppose this new circle over here represents another network to which this box A has to move. Now, this brings in another challenge, like uh, now suppose this A has now moved to here, but the thing is the IP address over here in this area may be 11.0.0.0, maybe the network ID of this new network. So suppose this was the network A being serviced by a wireless router named A, and then we have this another wireless router named B. So suppose we have these two wireless routers at our home just to maintain seamless wireless connectivity. So suppose one wireless router is not enough to cover whole of our home. So we install two wireless routers just to ensure that everywhere we get the wireless connectivity. Now the thing is, if we take the laptop from one room and we move it to another room, and if in both the rooms the IP addresses and things are little different, then how the things are going to work. That is the discussion about the mobility in the internet. So hopefully you understood the problem, what we are going to discuss today. Yes, let me know if you understood what we intend to discuss today. Have you got the problem? All right, great. So now let's move on. Share this picture back with you. Because as per the previous diagram that we discussed, let's now move on to this specific thing. Now, suppose what happens is this node over here is the sender who wants to send data. Now, suppose this was the original location or the home location, what we call the home location of the mobile host, which was the intended recipient. So the actual sender does know that the receiver is over here, means if it is a geographical area, then the receiver is in this part of the geographical area. Now, if the mobile host anyhow moves because of the random mobility pattern due to traveling or anything, and it goes to over here, one possibility is at all time instances, you will keep every other router in the network updated with the mobility information. So, what is your opinion? Shall we do that? That once a device moves one part of the world to another part of the world, because of its mobility requirements. So we shall update the whole network hierarchy, all the routers, the whole network topology should be updated so that these changes can be reflected to the sender so that the sender can send data to this mobile host now. What is your recommendation on it? Shall we do it? Let me know what everyone thinks through feedback, guys. Absolutely. Even nobody agrees to it, right? Because the problem with that approach is going to be the number of updates required in the network topology, the topological changes with every mobile host moving from one part to another part, and every time the topology getting updated. So the network would never converge in such a scenario. Yeah, absolutely, Sumit. It will maybe. Technically, yes, it will never get settled as the number of hosts are so long, so big in number. Uh, it will never converge to a very finite point. So hence, the second solution is there that is being presented on the screen. So what is basically done is every device does have a home location. So whenever we buy, whenever we suppose let me take example of a wireless mobile network. Although wireless mobile network and WAN networks, they are little different, but I'm just taking the thing as for analogy. Let me clarify this thing for you, right? I'm just taking this as an analogy, not as an example. Now suppose you buy your SIM card from one of the city in Punjab. Now suppose most of you, when you live at Chandigarh, so you may have bought your SIMs from Mohali, Punjab, or somewhere like that, right? So that kind of becomes your home address. So that becomes your home address. And once you take that SIM card to any other part of India, wherever you go with that SIM, that new location is now going to be called your foreign address or your mobile address. Now the thing is how the routing in mobile host work is instead updating all the topology, how the thing works is the source always sends the data to the home agent, home network. So at home network, there will be a router designated as home agent. Now, what this home agent basically is, let's understand that. Home agent is basically a routing device that is capable of forwarding some packets. So hopefully this definition itself have made many things clear to you guys. So when the sender is going to send the packet to home agent, and home agent is someone who can forward the thing. Home agent is going to forward the thing where the recipient is right now in the foreign location. So hopefully you got this triangle. Got this much? Then I can proceed to these 4 and 5 steps if you have got this much. Yes, let me know, right? So once this mobile host, wherever it is, it gets the packet, it gets the data delivered. What it does, see, from the data it can read who is the sender, and as wherever it is, it can simply send the acknowledgement back directly to the sender. Now once the sender receives an acknowledgement, now the sender is going to learn where the mobile host is present right now. So in that, no complete topology of the whole network has to be updated. Only the first packet has to go via the home agent to the end host, and afterwards, once one of the acknowledgement is delivered to the sender, now the sender will know that the mobile network is now in this using this address and is in this part of the network, and can now directly send the things to this specific system over here. Got the thing? Guys, got this diagram? Now to do all this thing, what approach is followed is the approach of tunneling. See, if you remember, in tunneling, what we used to do is we used to encapsulate the traffic of one type of data into another type of data. Now, here what happens is, suppose when the sender is basically sending the data to this home agent further encapsulates the data and sends it in the form of a tunnel, over a tunnel, to this mobile address. Got it? Now there are quite a few terms over here, like as a step numbers are mentioned. Now let's focus on what each step means. Now, when every mobile device, when it moves out of the home area, what it does is it sends a registered care of address request to its home agent. Now this means once this mobile host goes to a new network, it sends a message to its home agent that I have now moved to this new address. Please update your database that I will be available on this IP address. So that is this first message, registered care of address. Is it clear? Guys, is it clear? All right. Now, once this home agent knows that where this mobile host is, any data coming to, okay, I will show. I have to show. See, when this device, let's have a whiteboard activity. Let's simplify the whole things. Now, suppose we have a few networks. Now, suppose this first network, this is my second network, and this is my third network. Now, let's label all these networks one by one. Uh, this is my home network, right? This one is my home network, and this is my sender's network. All right. So what happens is, once my node, now suppose this, let's make a new node over here. Now suppose this is my node. Once it moves from this home network to a new network called this foreign network, like this, what it is going to do is it is going to it will require to be registered with the home agent whatever changes has incurred to its location. So previously, if it was originally in its home network, no registration was required, no update was required, as it was already in its home network and everyone knows where the home network of one thing is there once it is registered at the initial level. Now, when it moves, it sends the information back to the home agent, and home agent makes the necessary entries in its record, or what you call the log for the thing. So when now the sender is going to send some data, that data will be received by this home agent. Now let me denote the home agent over here. Let me draw a home agent over here. Now suppose this is the home agent. Let's name it as home agent. Right. So everything that is coming to this host is coming through home agent. So when it was in home network, home agent simply sent, home agent is a router basically, simply sent it to this host. But when this device is not inside over here, what this device is going to do is this device is going to register itself when it comes to a foreign network with the home agent. So now the home agent can forward the information to this node. Ayush, hopefully this thing is clear. I tried to simplify the whole thing. If any other doubts, guys, like Ayush just told me that there is something that needs to be done. Don't be IGMP version 1. I used to call it again and again. Don't be IGMP version 1. Don't let the router ask you again and again whether you are there or not. You yourself give me the feedback whether or not you are any longer the member of the group. Be a IGMP version 2 or IGMP version 3. Don't be IGMP version 1, right? So let's move on. Anuj is V3. Great, Anuj. So right now you're not listening to me, you're listening to someone else as well. Anuj? All right, great. All right. Let me share this next screen with you and then we'll move on. Now, our next discussion is just going to be on the field of mobile IP. Now, we just studied about how the mobility is going to be dealt in the network, but let's understand how in the terms of internet protocol, that means at the network layer, how the whole thing is basically managed and is dealt. So, suppose what happens now is for every device you have a home agent, which is basically a router at your home network, and you have a foreign agent as well, which is a router in your foreign network. So when the device was in the home network, suppose it was connected this via this wireless transceiver, via this wireless router, and it was getting connectivity through the router to the internet. When it moved to this new location, then what happened is there is also a router which is making taking help from this foreign agent through this foreign network, going to the wireless transceiver, and eventually going to this mobile node. So that is how this whole thing works in the form of IP. Now let's take a few more examples to this thing. Before we go on to this thing, let's have a small poll question from you guys. So if the device moves to the new network, shall we make the appropriate updates on all network devices? What is your opinion on this, right? So yes or no? If the device moves to a new network, shall we make the appropriate updates on all network devices? Absolutely, Anuj. This is the reason why roaming charges are more because they have to manage this log with the home agent and the foreign agent, so the kind of extra burden is there on the whole network. Especially when it comes to roaming some foreign countries, at that time you people actually realize what you basically mean by roaming charges. They are huge, so technically buying a new sim costs us less in comparison to if we enable the roaming when we visit any of the foreign countries. So a humble suggestion: if ever you guys move to a new country, buy a new SIM from airport as well. So my recommendation is buy a new SIM card from Delhi airport if you are going somewhere abroad. Uh, that SIM card that works in that country. The counters are there, and just buy a one. All right. All right. So Akash, how the WhatsApp calls are supposed to work if you will not have internet connectivity on your phone. Now, the issue with the international roaming is if you want to go to a new country, you may have the airport Wi-Fi hotspot, although available over there, but the problem with the airport hotspot will be you will have to enter the OTP that you will be receiving on your phone. And the problem with most of the internet, most of the service providers of India, like I had this idea a provider with me when last time I visited abroad. So the problem was there was no incoming messages, nothing like that when I left India. So that was a problem, big problem. So I was not able to even connect to the airport's hotspot, and hence, as no internet connectivity, no WhatsApp calls, and nothing like that. Okay. Yeah, I'm just sharing my experience, the thing that happened to me. Although one of my co-traveler had this other solution that I told you earlier, buy a SIM from Delhi airport that works in the other country. That is the most appropriate thing. Spending 2,000 or 2,500 rupees on a SIM is not going to be regretted in future, because that will help you guys a lot in case you ever visit a country like that. So go prepared for that. So guys, coming back to this question that has been asked over there as a poll: if the device moves to a new network, shall we make the appropriate updates on all network devices? The answer is no. Actually, it is going to be very expensive. Uh, Okay, coming back to what Sumit asked, can we use natives hotspot? Sumit, the problem is not all over the world people are so friendly and helpful sometimes, and especially when you are coming from a different ethnicity, especially some of the people over here in India, they have made such a bad reputation when it comes to loyalty. So some people don't have very good impression about Indians in some places, what I have observed while visiting places. So a few people who have ruined the image is costing everyone a lot, so it is the harsh reality, right? So can we move on, guys? Shall we move on? Shall we discuss this thing that is there on the screen? Okay. So over here now, how this thing works in terms of IP addresses. Now suppose you have this remote client which is trying to send, and the client remote sender has this IP address 56.172.78.22, and it is trying to send data to this IP address 71.13.240.20, which is the home network IP address of one of the mobile node host. So this was the IP address of that system. But now, suppose this mobile node now moves to a new network connected through a foreign router, and this has this new mobile foreign location. And previously, suppose the home network was somewhere in London, whereas this device has now moved to Tokyo. And yes, both the networks, the network IDs for London and Tokyo, as they are geographically separated from one another, so the network IDs are going to be different. Hence, both the networks are represented using different network IDs. Now, the thing is, all the packets, they will be routed to this specific IP address that is supposed to be here. Now, once the packet reaches to this home router, the home agent will be forwarding all those packets through a tunneled way. So once the packet comes to this router, if the mobile devices move to this foreign location, it will be sending those packets through any of the mobile network to this mobile device, as I showed over here using this red line. Got it? Guys, did you get it? Now the thing is, to this remote client, only this IP will be visible. That means to end host in internet, to this home router, the things will be coming, and technically it will be encapsulating the thing and sending it as a tunnel to this device. So a very important use of the tunneling concept, very important use case of tunneling is this one: when you have this mobile device moving from one part of the world, to the other part of the world. So let me know, guys, have you got this thing? Let me know through got this thing, how a mobile device is going to work once it moves from one part of the world to another part of the world. Now let's have a pool question with respect to this. Uh, Suppose the question is, if the mobile device moves to a network with IP address say 200.9.9.0/24, and the home address was 192.168.0.0, where the packets will be sent by the uh, where the packets will be sent by the sender to the home agent or to the foreign agent. What is your opinion on this? What's your answer to this question? If the mobile device moves to a network with IP address 200.9.9.9.0/24 and the home address was 192.168.0.0, where the device the packets are going to be forwarded to whom? The question couldn't be written because of the limitation for the question, and so I'm completing the question. Where the packets are going to be sent by the sender. So sender will send the packets to home agent or to foreign agent, where the packets will be sent by the sender. That's my question over here. You guys got this question or not? All right. Sumit, this comment. In such case, you can post questions in chat box and opt in poll. Yeah, Sumit, a good option. Next time we can do that as well. So there's again repeating the question, those who are not getting it. In the mobile device, if the mobile device moves from a network uh, with this new network have this IP address 200.9.9.9.0 and the home network was 192.168, where the sender is going to send the packet. So options are to the home agent or to the foreign agent, where the things are going to be sent. First packet to the home address, absolutely. So the first packet will be sent to the home and it will be routed. So both the options may be enabled. See, I'm again repeating this one thing. Initially, when I started, don't confuse the WAN with the mobile network, with the 3G or 4G network that we do have in our cell phones. Our cell phones network based on the cellular network form. We will discuss that in a little while. It works in a little different way. It has handoff mechanism, although it also uses this foreign agent and home agent based approach, but it works in a slightly different manner than what mobile IP is. A very common example with the network layer issues and all. Suppose you are logged in into Skype, right? And you move from the range of one Wi-Fi router into another Wi-Fi router. Uh, have you observed that the connectivity gets lost and we have to re-log in into the device? That the Skype re-logins. Have you ever observed it in hostel? Most of you guys were hostel before this lockdown time. Yes or no? So with confusion regarding which what you know. All right. Again, my question is okay. This poll question is clear. The answer is going to be option number one. Now the question I ask now is: suppose you are using Skype, right? And you are connected to Wi-Fi router, and then while talking to someone on Skype, you keep on moving, and suddenly the range of one of the routing device, one of the Wi-Fi router goes off, and you get connected to another Wi-Fi router. Maybe the two are in the same network area, but still you get switched to another Wi-Fi router. Does Skype reconnects, or the seamless call keeps on ongoing? What is your observation? Have you ever observed it? Well, Sumit, hopefully this question is clear now. Sumit, this disagree is for understanding question or disagree to the observation? Okay, yeah, great. Because I started to worry this time. All right. So, guys, you may observe that in most. Okay, another thing. I have one for you. Another one for you. While talking, while this WhatsApp call is ongoing, and the wireless network, when it switches over, like this handoff takes place from one network to another network. Have you observed this? WhatsApp call also gets reconnected for a little while. Have you observed it? That reconnections are there. So those reconnections are because we move from one network to another network. We may be already in a foreign location and we may have moved to another new foreign location. That may also be the case. So even in that case also, the information in the home agent has to be updated again, right? All right, Ayush, that's a new one for me because I'm not using BB on my phone because I can't take that much of risk. I cannot explain a thing to people who are not technical with computers and all those things. So that's the hardest thing to do, right? When someone questions you and you know what is basically going on, but to make someone understand what's the problem, it is very, very, very hard, and that's kind of job when it comes to the sport job as well. Now let's move on. If this much thing is clear. Now, a few more discussions on these things. This was the problem. Now this life of patience. The thing I just showed you previously, that this way the things are going to go to this new router now. This diagram is illustrating that. Now, coming to this thing about the cellular network. Even in the cellular network, it works a lot like your the thing that we just discussed. Now, suppose there is this computer network which is also connected to the internet backbone. So, what do you mean by the term backbone, guys? Can someone tell me what you mean by this term backbone? What you get from this term when you hear to this term backbone? Yes, just let me know what you understand when you hear this word. I'm not asking its technical meaning. When you hear this, the main sport, absolutely. The main sport, the central network, absolutely. Yes. So just like our spinal cord, so our spine basically holds every part of our body together, kind of, because the lower portion of the body, the middle portion and upper portion till our head, everything till our skull, everything is holded together through the spine. So spine also carries all the signals from the brain down to every other part of the body, because the nerves pass through the spinal cord. That is all I know about the biology and all. But that's the same logic with the internet. So when you have a network with big capacity which carries all the data through it, it is made like a big highway. So that is what we call as the backbone network. And all the small networks, they are kind of connected to the backbone network. Now, in your network, there are many types of mobility. Like suppose, oh, you will observe there is this router and there are further some routers, and every router is taking care of some of the cell. So this is the cellular structure of our cell phones as well. Our mobile network, it works in a hexadecimal cellular form. So this hex represents the area of one of the router. Can someone give me a possible logic why they haven't represented circles over here? Do you guys actually think that the mobile range goes in a hexadecimal X form, X shape, that it will be covering straight lines like this hexadecimal, like this hex form, diagrammatical form being shown over here? Do you think really this thing works like this? What is your opinion? No, absolutely circle, right? Now, why this hex is chosen, a very interesting fact behind it. If you choose circles, you will have either of the two options. So let's show that. So either the circle is going to be smaller one like this. So in that case, what will happen is spaces between circles will be left blank. So there will be some ranges. Yeah, absolutely. The football concept. So I totally agree. If all will be circles, small patches will be left blank. And if they create big circles, there will be unwanted overlaps, which we don't want to show graphically. That is why our cellular network, the cells are represented in hexadecimal. Basically, the network, as it is omnidirectional signal, it goes like a circle. Basically, it goes like a circle. It doesn't goes like any other form, right? Clear, guys? Guys, clear? Let me know. All right. So when your device moves from one of the see now the cases are in case your device moves from one of the mobile net mobile tower to another mobile tower, but if both the mobile towers are being serviced by the same router at the top, so that means it is a link layer mobility. So local mobility will be considered. So only one router, one network, if it is catering to both the source network and the destination network in our mobile network, it is going to be called as mobile local mobility. In case it is being serviced by the local same network, it is going to be called link layer mobility, also known as L2 mobility. So if something is getting changed only at the Ethernet level, not at the IP level, that is going to be called as link layer mobility. I think there is some question. This PM IPv6. Basically, this PM IPv6, you call it for proxy mobile IPv6. When you have a big network and you have some of the devices which are working on the behalf of some other network that is there, this is proxy mobile IPv6 network. Got it, Anuj? These are not basically the satellites, these are the networks. So ISPs, they deploy these proxy mobile networks just to load balance the whole thing, so that one of the point doesn't create single point of failure, and also to deal with all those problems, this kind of architecture is made. So now see, we have discussed link layer when we have this local level router between two cells. When we have to go through this router and then reach to the destination. This is local mobility. And when we have to even go through the whole network and go into a different domain of networks, this is going to be called as the global mobility. So usually previously what used to happen is this local mobility was free when it came to roaming. This local mobility then also kind of became free, that even if while we were roaming from Chandigarh to Punjab, initially this was also considered as roaming, but later on they modified it. It is a long old story. So later they modified the approach. Chandigarh to Punjab, it kind of became local mobility, and now this tri-city and with this geo emergence, the whole India is kind of local mobility nowadays. But previously this was considered to be a global mobility, and that's why it was expensive previously. Hopefully these things are clear, guys. Guys, hopefully these things are clear. Let me know. Now let's have another one. Now, how basically the registration of devices, Ayush, link layer mobility is the one where you basically do not have different network IDs with you. A great interesting question. Okay. So if you have asked, let's discuss this then. Suppose I have this square represents suppose a building, and in this building there are different levels like These lines, they are representing different floors on the building, and all these floors, they have separate mobile routers on them. So suppose let's have these. Uh, Let me have this one router over here, another router over here, another router over here. So now suppose what is happening is you may have different rooms on this floor one. So let me name it as floor one, this is floor two, and this is floor number three, and this is router number one. So if you have multiple devices on your this floor one being served router one, so you have this room and then you have this room. So there may be further access points installed in these rooms. So both the access points may be serviced by this single R1 itself. So even if you move from this room to this room, still you will be serviced by this router R1. So this kind of mobility is going to be called link level mobility. Got it? Ayush? Hopefully you got it. Uh, okay. Any other doubts in any other kind of mobility, guys? All right, great. So now let's move on to our final discussion point from this thing. Overview. Right. Now, guys, see how the registration and the whole thing works is when the mobile node moves to a new foreign agent area, how it does is, see, all the agents, they periodically sends what is known as agent advertisements. So these are kind of broadcast messages. Those are periodically sent by the agents. So they are also sent by home agent. They are also sent by foreign agent and everyone. So when a mobile device receives a advertisement that is different than its home agent, so when it hears something that is not familiar, so something which is heard new that is not familiar, so obviously it is something which is foreign. So now this mobile node sends this registration request to this foreign agent that I need to register on your network. Now this foreign agent forwards this request to the home agent of the mobile node, and if the home agent authenticates the registration to the registration reply, then the registration reply is further responded back to the mobile node, and only then the mobile node is allowed to communicate while it is roaming on any of the network. So you may observe even when you go on a network and when you are roaming, you will observe that the registration time is little longer than when it is on your home network. Try switching between manual and automatic networks and try observing the time taken to switch between the networks. On your foreign networks while you are roaming, it will take quite long in comparison to your home network because of this thing, as the requests are forwarded to home agents and the responses are waited back. Got it? Guys, did you get it? All right. Any questions from this? Because that is all that was there from all required from your unit 2 part. So I think we have done more what was already listed there. So still, if anything is there, please do let me know. If anything needs to be reviewed or anything. If you guys plan to have any extra session during these Diwali holidays, we can also plan something for that as well. Anuj, course not finished, only unit 2 part finished. We still have the unit 3. Okay, Akash, this question, is there any case when registration reply is not sent by home agent? No, Akash, foreign agent does not know the legitimacy of the mobile network just to authenticate it and also to update the information to the home agent. This registration reply will always originate from the home agent and will never originate from the foreign agent itself. Okay, Akash? All right, great. So guys, that's all for today's theory session. So we will join back at 11. So today in practical, we plan to do, because we have done the syllabus practicals, we have done all the 7. So today we'll be going beyond the syllabus and we'll be looking at network address translations, NAT based practical. So hopefully you guys will enjoy that. So see you guys at 11 and get prepared, be prepared for new exploration. See you guys.